Okay, logarithmic differentiation. This is just just another way of finding derivatives. So sometimes it's an easier way to go. If you have like a huge big mess, sometimes it'll help you, sometimes it won't. But if you practice with it, you'll find out that it's a good thing to learn how to do. Okay, so the first thing I did is I just kind of wrote down here. We're kind of going back in time here, and we're looking at taking the derivative of log of x and how easy it is. And I tacked on dx just to imply the chain rule. Ooh, oh, good. Something in my throat. So we're basically just going to apply the same principle. So I'm going to use a real easy function right here. Okay? So I'm going to go y equals 2x. Okay, so we all know how to take the derivative of this piece of cake. Okay, but just the logarithmic example says that, well, we can take the log of both sides. In this case, it's the natural log. Okay, so how do we do this? So here's the next step. So this is going to be 1 over y. Okay, business as usual, except we're looking for dy dx. Okay, so we're going to have to use implicit differentiation. Okay, and we just stick the deal in there. Next thing we do is we do 1 over 2x times the chain rule. Okay, so that's equal to 1 over 2x. Okay, then multiplied by the chain rule times 2. So we end up with dy dx times 1 over y, and that's going to be equal to 1 over x. Okay, so it didn't matter. Okay, I guess I should have, to be proper, I should have wrote my dx's over here. And by the way, let's just make a note that that's 2, y prime is 2. Okay, so if I multiply both sides by y, okay, it looks like these will both cancel out. Okay, and then my derivative, this is what I'm after. Okay, this is what I was after at the end of the day, is equal to y over x. Okay, so now we take a look back here and we say that, well, what was y equal to? Well, y was equal to 2x, wasn't it? So we can go ahead and just substitute that in there. And y was equal to 2x. We're just plugging it in. Oops. Sorry. And I'm getting ahead of myself. Now they cancel out, and then I'm left with just 2. Okay, so we already knew that, yeah, but I'm just kind of showing you, I didn't want to start off right away with like a crazy, some hipster crazy example. Okay, so there we go. Alright, next one. Let's go, what do they have? Hopefully I have time for this. It is 2x squared plus 1, parentheses, over square root of cosine 2x. Alright, well, let's see if there's anything we can do here. So if we take the log of both sides, okay, we're going to end up with natural log of y equals natural log of 2x squared plus 1 divided by sine 2x. Keep in mind we took the log of the entire thing. So I see some algebraic simplification here before we even take any derivatives. Okay, this is just going to be, how's it going to work? That'll end up being natural log of minus natural log of cosine 2x to the 1/2 power. Okay, so let's see here. Let's go ahead and do some more simplification. And we're going to have natural log of 2 x squared plus 1 minus, I'm going to use my power rule, logarithm power rule. And there we are. Okay, Now I think we can do our little differentiation. Okay, so I'm gonna take the derivative of the first. That's gonna be 1y dy dx, and this is gonna be it's gonna be, pull the constant out. Remember, I'm taking the derivative of this entire thing, so I guess to be proper, we'll want to go ahead and do that. Okay, so I know the constant comes out. We're going to move this downstairs, and then we're just going to take the derivative of the inside with the chain rule. So that'll be 2x minus 1/2. Derivative of this, that's 1 over cosine, or that's 1 over cosine of 2x. So that's cosine of 2x. Use the chain rule, then we get -2 sine of 2x. Is that right? I think so. Okay. So it looks like we have some more simplification up our sleeve. So I'm going to cancel out these 2's. I'm going to cancel out these 2's. And I'm going to divide everything by y. Actually, I'm going to multiply everything by y to get dy dx by itself. And that's going to be y over what? X over x squared plus 1. Negative times negative is a positive, so that's sine 2x over cosine 2x. Let's just call it tangent of 2x. Okay, and in the beginning, oh, I didn't even put that on there, I'm sorry. In the beginning, what was everything worth? It was y was equal to this guy, so we got 2x Did I put that on the page? Alright, at least I did that right. Okay, and that should be our final answer right there. Hopefully I didn't mess up anywhere. So you can see that, our first example was pretty nice. This one wasn't really that nice. So just taking a look at this thing, would it have been easier? I don't know. It looks like we would have had to use the quotient rule and a couple chain rules. So I don't know. It's kind of arguable whether this would have been simpler to do or not. So I actually think it would probably have been a little simpler to go with the quotient rule. So I'm gonna say the logarithmic differentiation didn't help us there, but it sure did us some good practice because we rewrote this. We even went back to algebra and did our logarithm rules. We used our power rules. We used the quotient rule for logarithms. Then we used everything from implicit differentiation to the chain rule to algebra, and a little bit of trigonometry. So took a little bit of everything right there. Whereas the quotient rule probably would have saved us some time. So that's all I have there. That was a tricky one. So if you didn't get it, like always, leave a comment, send me a message, and maybe I'll do a cleaner presentation of this problem. It was a good one. Okay, I will see you in the next video, and thank you for watching.